Maybe can you explain to us how do we remember how Amine looked like? I think during the example I did tell you that, oh, this is how I remember. I did.
I definitely did not somewhere.
Are you sure everything that comes is all here? Then you feel that no need to take down because everything is here, right? Right or Lachita, correct?
That's not improbable.
Or any ladies want to help out our only gentleman for today?
How your evening looks like?
Yeah, how do you count with Amines? Like Amines, we have primary, secondary, tertiary, but in general, how do you count with the structural form for Amines? That time, how do I share with you how I remember that? I remember, I confirm got share with you. So you know any memory of how I
Chapter was
So, but I didn't do it in school.
no. How do I say? We haven't really do Amines, but Amy was one of the new profile we bring in during one of the reaction. So you hear me? I know how many out here. My question is very simple. All right. Amines to us is all a bit unfamiliar ground, right? So how do we recall how does it look like in a very fast and easy manner? All look at me.
your question.
Okay. Okay, we all know, for example, hydroxide OH minus, right? The formula we know. How do you recall the formula of amine easily? That's all I ask.
Just add down to 3 things more.
Okay, basically, we are very familiar with this pungent gas, right? Ammonia, right? So all you have to do is just draw out ammonia and with 3 H's, right? Just randomly replace 1 H with a carbon chain. That will be your primary. Replace another H. That will be your
Secondary.
replace one more H. That will be your yeah. So just remember your pungent gas.
You're thinking about something more like.
Oh no. That is that's why I said you don't think too much. Your issue is you think too much, right? My question is really that simple.
Okay.
That's because that's how I remember also. Yeah. Otherwise, sometimes I also confused. Amines, I'm gonna so many things you see. Okay,
Yeah, I thought it was something like super concentrate.
No lah. Okay, then I'll continue. Okay. Then of course, remember the acronym is not acronym, strategy association. So remember your most common bench reagent, right? Aqueous form meaning you start with a solid sodium hydroxide. You just add water lah, it becomes aqueous form now. So this is just substitution. So replacing the Cl with the OH, that's it. Okay. Of course, because it's substitution, we will have byproduct, but we seldom bring the byproduct. Okay, just for fun. What is the byproduct? This is not balanced, but substitution means something must come out, right? So what do you think is the byproduct? This one. What's the byproduct? Any OH, any Cl. Okay. We just know. Okay, anyway. Then after that, how do you get ALC? ALC meaning alcoholic medium. So the most common alcohol that we use as a solvent is ethanol. So that's why sometimes in your lecture note, right, they write ethanolic. Can you see my spelling? This is not a D, this is an OL. My goodness. I'm sorry, you have to get used to my handwriting again. Lashita, do you need handwriting?
I mean, mine is not.
Wow. You know how to talk very good. Sorry, you were saying.
Mine is not much better. So.
No. Seriously, all of you here handwriting is much better than mine. I always get criticized by my own daughter. Mommy, can you write properly? It's okay. Anyway, okay. So the most common one is alcohol, ethanol. That's why in the lecture notes, right, you might see ethanol in NaOH. Okay. So basically, just from a solid NaOH solid, right, just add ethanol as a solvent to dissolve. That's all. That's how we get aqueous form and ethanolic form. Okay. So this is elimination. All right. Over here, because I only have 1 H and 1 Cl attached to adjacent carbon, so I only one way. But for both of you who uses chloropropane, you have 2 ways, but the 2 ways will end up with the same product, right? Yeah, so it doesn't matter.